Okay, so now we're going to look at the second core principle or core understanding that you will need to comprehend in order to better understand physiology. And then that core principle is understanding ions. Now, before we can talk about what an ion is, we need to step back a little bit and talk about where they come from. And we have to talk about what the atoms are. So when we talk about atoms, the first thing that we think of is going to be the periodic table. And then the periodic table is this, okay? So we have all the different elements on this periodic table that we need to deal with. And the common ones that we're going to be seeing, that we're going to be looking at, we're going to be looking at the sodium one here. We're going to be looking at potassium. Those are going to be two big ones that we will be talking about throughout this semester. We're going to be looking at calcium on this one, okay? But let's go through some of the basics of the atom, and then we'll go from there, okay? So the first thing that we're noticing when we're looking at an atom, not any one specific atom, okay? Let me just scroll up a little bit. Atoms will have three subatomic particles. We're going to have let me just do this here. So an atom, you're going to have a nucleus, and the nucleus is going to be made up of protons and neutrons. We'll go into that here in just a second. And then we're going to have electrons that orbit around the nucleus, okay? And these orbits are called shells. Now each orbit, each one of these shells can hold a specific number of electrons, okay? So let's just do this real quick here again. So the nucleus has protons and it has neutrons. That's an E, neutrons, okay? Protons are carrying a positive charge. Neutrons, there's no charge, neutral, okay? And surrounding everything, then we have electrons. And electrons carry a negative charge, okay? So each proton would be represented with a +1. So if you have two protons, that'd be represented by +2. If you have one electron, you would know that as a -1. If you have two electrons, that's a -2, or 3 would be a -3, and so forth, okay? So for an atom to be electrically neutral, meaning it doesn't lean positive, it doesn't lean negative, the number of protons will equal the number of electrons. So when we're looking at the periodic table, if we go back up to this, if we look at sodium, you can see this number way up at top here, and that number is 11, you can see. That number is the atomic number, and it represents the number of protons. So each atom, the number of protons equals the number of electrons in order to be electrically neutral, okay? So in this picture here, let's say we have the sodium, we have 11 protons, so therefore we have 11 electrons. And now we're going to focus in more so on just the electrons right now. So let's look at these different shells. The innermost shell, the shell that is around the nucleus, the closest, can only hold 2 electrons. So let me put those electrons in green here, okay? So the maximum number that inner shell can hold is 2. Once that shell fills up with 2 electrons, then a third electron starts filling in the next outer shell. So we have another shell here, and these outer shells can hold up to 8 electrons. Just a general rule. We're not a chemistry class, so let's just, for argument's sake, the outer shells, okay, beyond the first inner shell, can hold 8 electrons. That's called the octet rule. So this one can hold 8. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, so that one can hold 8. So now our total number of electrons are 8 plus 2, which is 10. Now we said the sodium had what number? 11. It had 11 protons, so therefore it has 11 electrons. So we have one more electron missing somewhere. So let's do another electron in here. Okay. And now we have that one more electron. So if you count up all those green dots, for sodium, there's 11 electrons. This represents an electrically neutral atom. You have 11 electrons, or 11 negative charges. You have 11 protons, or 11 positive charges. So 11 minus 11 gives you 0. Okay? Now, if we change the number of electrons, then we are no longer electrically neutral. So the two concepts we want to be, the atom is electrically neutral when the electrons and protons equal in number. Okay? The second principle is that the atom wants to be stable. Not just electrically stable, but it wants to be stable. By that I mean that outer shell, let me just do a red here, this outer shell wants to be filled up. Okay? And if it's not filled up, it's going to do whatever it can do to fill itself up. And in the case of sodium, let me just write down here, this is sodium, Na is sodium, okay? In the case of sodium, we have one electron on its outer shell. So we've got basically two options, okay? And we're going to take the easier of the two. The two options are, well, we add 7 electrons to this outer shell to fill it up to give you 8, or we give up 1 electron. So what would be the easiest thing for this atom to do? Take on 7 electrons or give up 1 electron? The easiest thing for it to do is to give it up or donate the electron. So this electron goes away, okay? And then that fills up this shell with 8 electrons. So it's a stable element, okay? But it's no longer electrically neutral. Now, why is it no longer electrically neutral? Well, sodium has 11 protons, and before we gave up this electron, we had 11 electrons. So we had 11 protons, 11 electrons, electrically neutral, okay? But now we have 11 protons, 10 electrons, because we gave up this 1 electron. So 11 protons, 10 electrons. So we have 1 extra positive charge. So this element is electrically positive. So when you see sodium represented, you will often see an Na+. This plus sign basically means it's got a positive charge. Okay? So that's one of the things that we're looking at on here. Now, the same can apply for chloride. Okay, so let me do chloride here real quick. Let's do the nucleus here. Okay, and chloride has, as we saw, let me go back up to here. Chloride has 17. So 17 protons, 17 electrons. So let's go back down. So our inner shell has 2. Okay. Then we have another shell that has 8. I need the green color here. 1, 2, 3, 4, 5, 6, 7, 8. So now we have 10. Okay. Let's do another shell. So we have 10 here. So that's 11, 12, 13, 14, 15, 16, 17. Okay, so this would be chloride ions in this case. Okay, so here we have a number of 17. This one was a number of 11, okay? So we have 17 protons, 17 electrons. This right now is electrically neutral. But overriding that, the atom wants to be stable, meaning the outermost shell wants 8 electrons, okay? Here, we've got 1, 2, 3, 4, 5, 6, 7. So it's not stable. So again, we're faced with two options. Do you give up 7 electrons, or do you take on 1 electron? And it's the easiest thing to do is absorb another electron. So at this point, this one will come down here. Let me just do this. I'll tell you, and at this point, that electron comes across. Okay? So now we've got 18 negative charges, 18 electrons. We have 17 positive charges, 17 protons. So we have one more negative charge than we do positive charge. So this is represented as a negative. So when you see symbols, you will see me writing throughout the semester Na positive, okay, and Cl negative. That gives you what an ion is. So these are ions. Ions are when you have donated or received or accepted an additional electron. You've donated an electron or you've received it. Now, how these two work together are going to be based on chemical bonds. Now, there's 3 different types of chemical bonds that we've dealt with. If you've had chemistry, you know that there's a hydrogen bond, which we're not going to talk about. There are covalent bonds, which we'll talk about in a second. And then there's an ionic bond. What we're seeing here is an ionic bond. So let's look at, I'm trying to figure out what I did with it. There we go. So this is what I just drew a little bit easier. It shows it a little bit better to you on this one. This is what's called an ionic bond. Okay, and these two elements are quote-unquote bonded together because one has a negative charge, one has a positive charge. So they're attracted to each other based on their electrical charge. Now remember, opposites attract, okay? So a negative charge is attracted to a positive charge, and so they hang out together, all right? Pretty simple. Think of magnets. So remember when we were kids and you're playing with magnets and either they repel or they attract to each other? Well, if you've got a negative one on this side and a positive on this one, they're attracted and they'll stick together. But if you flip one of them over, they want to repel each other because it would be a positive to a positive or a negative to a negative, okay? So an ionic bond is where the two elements are attracted to each other. We'll close this off. We don't need this. Are attracted to each other based on their charge. All right? So that's going to be one thing. The next thing that we're going to talk briefly about is going to be covalent bonds.